Welcome to Effects PhD C4D 218, which is an intermediate to advanced Cinema 4D course on procedural layer shader and texture map creation. I'm Tony Coppolillo from COPO, and as a former FX PhD student myself, I'm really excited to be a part of the team as an instructor. The 10-week course is going to focus on using the built-in tools of Cinema 4D to create multi-layered shaders and complex texture maps. I'll be bouncing between R16 Studio and R15 Studio because I know not everyone will be up to speed with R16 as it just came out prior to the recording of this semester. We'll also compare the new material editor to older versions in another class, as well as the limitations of C4D Lite that ships for free with Adobe After Effects CC. So if you have a Creative Cloud membership, you have access to the newest version, which at the time of this recording was R16. And that includes the reflectance channel, so you'll be able to follow along with some of the newer techniques, as well as recreate some of the legacy shaders from the other classes. And there's also access to Cinema 4D full version on the FX PhD VPN, in case the version you have doesn't support the features in some of the classes. In addition to the procedural textures we're creating, we're going to build some low poly models because we need some objects to put those textures on. And hopefully you'll pick up some quick tips and techniques of modeling along the way. The procedural textures are 100% computer-generated materials, which means there's no pixel-based imagery used. And yes, it's easy to slap a digital photo onto an object and make it look photorealistic, but this is more about knowledge versus speed in both understanding what makes up the images and the objects around us and how to use the tools in your software program. And that just makes you more valuable as an artist with a bag of tricks when your client's calling on a deadline and you have to come up with a unique solution. And we won't be using any expensive third-party plugins like V-Ray or X-Particles, and we're going to stick with the C4D standard and physical render engines with and without global illumination. And the reason I'm doing this is not all of us work for large companies with deep pockets, and some of us can't afford to buy licenses for every available piece of software out there. And yes, some of these programs certainly do better jobs, but they come with this steep price tag. So for the struggling independent freelancer out there, we're going to create everything off the shelf. As for week 1 in the class, we're going to be discussing theory more than the actual process of building these textures layer by layer because we'll cover those heavily in future classes. We're going to discuss the difference between pixel-based images versus procedural generated algorithm shaders, and we'll look at real-world photographic reference to see what makes up an object and examine those elements' textures. And then we'll discuss the capabilities of recreating those in Cinema 4D and the material editor, and look at the content browser for some amazing objects that were shipped with Cinema 4D. These are fantastic reference. I highly recommend you take the time to look through this, open these files, look at the materials layer by layer, and see how these people built these. They're absolutely mind-blowing, and this is what actually inspired me to pursue layer shader creation in the first place, because I looked at these and I said, that is amazing, and I said, wait, why can't I do that? And I can, and so can you. So let's jump out of here and get into it. As I mentioned earlier, we're going to discuss more of theory in this class than the actual procedure of building these textures in class 1. So let's start with explaining what is a procedural texture. So according to Wikipedia, a procedural texture is a computer-generated image created using an algorithm intended to create realistic representation of natural elements, such as wood, marble, granite, metal, stone, and others. Usually, the natural look of the rendered result is achieved by the usage of fractal noise and turbulence functions, and these functions are used as a numerical representation of the randomness found in nature. That is a perfect explanation, and I'm glad we came to Wikipedia for that, because what we're trying to achieve in this class is organic, realistic-looking textures, and we want to use the computer to create those, and we use fractal noise generators to do that. And I'll be showing you those in future classes when we're building our own textures, as well as in this class I'm going to show you some examples in the content browser that heavily use fractal noise as both texture maps, blended texture maps, and layer masks as well. But we asked the question, what is the difference between a procedural texture and a bitmapped image? So we'll switch over here to raster graphics on Wikipedia. This is basically describes what bitmap imaging is. And in my definition of it, it's resolution dependent. So that means the image you look at is made up of a bunch of pixels at a specific size, and you can only zoom in so far before the image starts breaking down, and that's shown in great example here. The closer you zoom in, you see the pixels. So with these procedural vector-based graphics, they're basically resolution independent, and that means you can continue to zoom in on these objects and they won't break down and they won't start to pixelate. So that's the advantage of using a procedural texture on a 3D model versus a Photoshop image, because if you ever want to zoom in close on the object, your Photoshop textures are going to start to look really blocky and chunky if you zoom in too tight. So some real-world examples. If we look at some wood textures here, Google Images is a great resource. I'm not going to include any of these sample images because I don't have the rights to them, but we can show them for educational purposes here. And here's this photograph of some wood. We'll zoom in and look at all of the textures that make up this object. So you've got wood grain, you've got vertical grain, you've got circular knots where branches go, and you've got smaller grain in here. And so these are great references when you're trying to recreate these textures. And again, the advantage of using a procedural texture is if you take a photo, even in this case, you can see there's a little bit of a light spill here. And this image you'd have to tile and you'd start seeing a repetition. So if you had to cover a large area in this wood, you're going to see this knot repeat over and over and over as a tile. And then you'll have to go into Photoshop and darken this vignette of light that's happening over here, and you'll have a hard time kind of blending these together. So yes, photographic elements look amazing and very photorealistic, but they're a lot harder to manage. And let's face it, in most cases, we're going to use photographic-based elements in combination with procedural textures in the real world, but this class we're just going to focus on the benefits of the procedural textures in the first place. Another example here, some piano strings. We'll scroll down. I've got this image highlighted. This is pretty cool because we've got some metal and some fabric and different types of metal, and you can see how the light interacts and the highlights hit metallic surfaces in here. Another example is snow-covered mountains, landscapes. I'm pulling up this as a highlight for the fall-off shader that I'm going to introduce in Cinema 4D. There's a really amazing example file in the content browser that builds a mountain with snow that was really my inspiration for diving deeper into Cinema 4D to figure out how these shaders work. Fall-off shader is one of those, and it's really fantastic. Another example in the content browser, somebody modeled a bowl of grapes. So I'm going to look at this photographic reference of grapes here. Zoom in. This is an actual photograph, and you can see all this organic texture that's happening in here. You've got these lines that are happening across the surface. You've got this kind of waxy surface that's getting wiped off here. The subsurface scattering where the light is hitting the surface of the grape and diffusing under the skin and basically illuminating it from within. There's so many things going on here, and this guy in the content browser nailed it, probably more impressively than any other texture I've ever seen, because it is 100% computer generated. I'll get into that in a moment. Another example down the line I'll show. I did a tutorial a while back creating a pickle for a project I had to create, and there were no computer generated pickles on the internet at the time that I could find, so I just made my own, and I decided I was going to do a tutorial for it. So you may or may not have already seen that. I don't want to cover any tutorials I've already done on the internet, but I'm going to briefly tap into that one and another one that I did, which is a tutorial on building a layer shader for an eyeball. So again, those tutorials are online for you to watch for free, but I know you're paying for this class. I don't want to make you pay for something you can see for free, but I do want to touch base on those textures that I created real quick. And again, I did that using photographic reference by coming in here and seeing, okay, here's an eyeball. It's got some blood vessels in here. It's got these fibrous membranes that are happening in the where the pupil and the iris contract in here. So I wanted to recreate this using some layer shaders. So I'll I'll tap into that in a moment as well. So with that, let's go over to Cinema 4D and see what we can do. So for starters, I created a default scene here with the floor, some primitive objects, some lights in here. So when we render this, we can see what our scene's going to look like here. And I created a little test texture. Let's move our material editor off to the side. And I'm going to be using R15 for this example because I don't want to confuse people with the new settings in R16. Not at this level anyway. So let's talk about these procedural shaders, and hopefully you're familiar with Cinema 4D enough that you've poked around and you've used all of these yourself already. But if not, let's just quickly explain Fresnel. As you can see, let's turn on our interactive render region so we can see what's happening here, and turn off our specular. Fresnel looks at your object, and any polygons that are facing directly at the camera are going to be mapped with this value on this end of the slider, and any surfaces that are facing 90 degrees away are going to be mapped with the color on this end of the slider. So I can just right click and invert these knots, and you can see it switch the color around, and now black is mapped to the surfaces that are 90 degrees away, and white is what's facing the camera. And this is handy because, like I said earlier, it's used mostly as a mask, that any color that's facing the camera will be obscured, and any color that's facing away from the camera will get the value that's happening in there. But what I also like to do is I can cheat this, slide this knot over here, and tighten this up. This becomes kind of a faked rim light on here. I can even come into the color knot here, add a little color to it, maybe a little gold, and feather this out a little bit. And then this becomes kind of a rim light around an object. And you have some control over the color and how wide an angle that goes over the corner. And then this can be used in combination with a layer shader, where you can set its blending mode to like add or screen like in Photoshop, so it'll allow the other textures underneath to show through. So this comes in really handy using Fresnel for more than just a mask. Let's clear that and add the gradient shader. And in the gradient, again, you've got the same sliders with values on either end. And then you've got these the ability to map it onto your objects using 2D and 3D mapping techniques. The ones I use the most are U, which is left and right, V, which is up and down. And the other one I use a lot is circular. And you can also invert the knots on these. And then I use this a lot for masking textures as well. And what's great about these gradients is you can add turbulence to them. So they don't have to be perfectly smooth. You can change this number to turbulence, and now you get this kind of an organic fractal noise in here, which is very important when you're trying to create natural materials. And what's fun here is you can change the frequency, and this becomes an animatable texture. If we hit animate here in the window, you'll see it does a little preview, and then it plays back, and you can see that texture starts to boil in there, which is really handy and can be very powerful in combination with the noise shaders as well. In fact, let's talk about the noise shader now. Clear that, add a noise shader, and you can see how the noise gets mapped onto here. You should be familiar with all of these different styles. If not, go ahead and pick through here. Some of these I've noticed, like electric, for example, I think is actually a pixel based, or if it's not pixel based, I noticed there's some repetition in the pattern when I use this. So I actually try and stay away from the electric pattern, but Luca is a pretty good one. And what we can do in here is all of these noise shaders are very flexible because you can change the global scale on how it's mapped onto your textures. Then you have the relative scale in X, Y, and Z. And for example, if I stretch this in the Y direction, you can see that texture gets really tall on the object. And you have more controls down here for low clip and high clip. So this is kind of like pushing the gamma or blending between these two colors here. And now you can see how easily this becomes, you can see how you can use this as a pretty organic texture map for maybe like peeling paint or something like this. So these are very powerful tools. And again, these are all animatable as well. So you can change the animation speed in here, come up to the preview and hit animate. Give it a second. Now combine those with gradient masks, with turbulence. This, you can see how building these layers upon each other can become very, very powerful really quickly. Now another one of my favorite, let's just reset this because I messed so many settings up. Another one of my favorite noise shaders to use is the Varanois in here. It's got this kind of a bubble cell looking texture in here. And this is great because there's different values in here of gray to white. And what that allows you to do when you pull this low and high clip up, it starts forcing those spaces away, and you get different sizes and different values of these all with one noise shader without having to do a lot of extra layers to get, because normally you'd have to lay one down, lay another at a different size and a different opacity and so forth. So you can get that just with this one shader. And this is one that I end up using a lot for some organic textures or just adding, speckles or dents into things. And you have a lot of flexibility if you change the scales on these and so forth. This is one of my more favorite textures to deal with. So if you come in here, again, you should be familiar with these, like galaxies, kind of fun. You can add some spiral arms. This is animatable, so this can spin around, things like that. I'm not going to spend the time to go through all of these because we'll be here forever. But the one we want to talk about here is wood. If you click on wood, there's this legacy button. I'm assuming for older versions where it just did this ring type pattern. But now if you uncheck that, you've got more options for scale, rings, and so forth. And you can scale the noise up to be more appropriate for the object, to actually give you your object scale, because we all kind of have a reference of what wood grain scale is supposed to be. And you have more options to change the waviness of these and so forth, adding grain to the object. A good example of this can be found in the content browser. If I come over to the content browser and grab presets and then just search for wood over here. Let's close our material editor for a second, and we'll come down here. And I think I did sort by kind, just so it kind of groups everything together. And you can see all these different textures that are made up of wood. Now, a lot of these in the library are made with JPEG or TIFF reference, so they're using pixel-based imagery, but some of these are not, which is great. An interesting one in here is this wood shader. And it's not the greatest texture ever. I'm sure it's probably a leftover one, but it just lets you, by getting in here, digging around and looking at these textures, it basically lets you think about how people are using different shaders. For example, they're using the brick shader here, but in combination with these colors and a stacked layer shader here. If we go really deep, you see they have a noise shader that's stretched. It's being affected by a color shader which has a gradient map on it, which is now affecting that noise, giving it this colored look. It is now being blended in dodge mode with some extra grain. Those two are used together within the brick shader, and then you've got this plank material. And again, it looks more like a video game than a photorealistic texture, but understanding how people are stacking these things in here is kind of unlocking your brain to think how you can create some textures of your own. Here's a great example of a completely procedural generated texture in here. So let's open this up. It's using that wood shader that we talked about, but they're also using something called fusion. Now, fusion works a lot like layers, and we're in a layer shader currently, and that allows us to stack multiple textures on top of each other and use blending modes much like Photoshop, where you have multiply, screen, and overlay, dodge, and all of that stuff. And within each of these, you can set a parameter for noise, and again, this noise is being colorized by changing the default black and white. They can add a color, and they're using that low and high clip I talked about to kind of pinch out all the detail that's in there. That then comes out here into your layer stack, and then it's set to transparency and a blending type. So that gives you a different way to overlay. So if I turn these eyeballs out, you can start seeing. So here's your base shader, which is a fusion between wood and a noise shader. These two are then basically what they call fused together using a multiply mode at a blend of 45%. That becomes the base layer. Then that noise is added on that we just looked at, which has some splotches in here. Then a gradient is put on there. And now this gradient is set with these knots at these certain points. And then the mapping mode is 3D cylindrical. And we'll get into mapping modes later. And then a loomis, which is essentially kind of a way to fake some speculars on here that are more realistic than just using the specular within Cinema 4D. That becomes the color channel of this layer. Then they're taking that wood fusion and they're putting it into the bump layer. And then in the reflection channel, they're creating another stacked layer in here, again, using the cylindrical gradient, a fusion of the wood, a Fresnel that's going to mask off the... Actually, it looks like it's allowing... Yes, it looks like it's allowing the reflection on the edge, and then the loomis, again, in the reflection channel. All those in combination. Let's go back to our little scene down here, and we'll throw this wood texture onto the sphere. If you hold down Command and drag, puts it on all the objects. And then let's turn on our render region. And you can see it's using that procedural wood grain to also affect the bump channel in here. And we can do some fun stuff like put some deformers on here, and you can see these wood textures, these wood grains kind of follow along with the wood. And let's even twist it here. And you can see quickly you can start getting some realistic wood shades in here. That's pretty great. Like if we put our old wood shade back on there, let's see what that looks like on the bent cube. Okay. So that's basically the wood shader. So next up was those piano strings that we were looking at. Now this is really great because in Cinema, if I pull up our picture viewer here, this is a file from the content browser. And I changed the camera angle and the depth of field on it and rendered it. But I just want to point out, this actually almost looks better than the photographic reference from a real world piano string. That's how good that this artist did this in Cinema 4D. It's showing all the metal, how it's picking up all the specular highlights. Everything in here is just fantastic. Very well done. So it was worth digging in and seeing how that worked. And again, we'll be building our own textures, but for this introductory class, I just want to show you these are objects and materials that ship with Cinema 4D, and they're in your content browser. So dig around in here, search for things, search for piano. Now this may only be in the studio version under the example renders, but there are plenty of other objects and plenty of shaders in there that are just mind-blowing and fascinating to work with. So if we come over here and look at the piano string project, you can see they've got some display tags on here. So let's just turn these off so we can see what's happening in here. And again, let's just look at one. We don't want to do the whole tutorial on someone else's project here. But if you look at this, let's open this window and shrink that down and slide our material editor over here. Let's one by one, let's turn things off in here and look what's going on. So let's turn everyone off. And let's start here at the base with our color. Our color is just using that loomis shader. It's basically adding some specular and a couple of different pings of specular in here. A smaller one, a wider one, and it fades off. That's all he's using for this base layer. He's got a diffusion layer in here, and the diffusion is just using noise. And you can see as soon as I turn that on, that really breaks up that highlight in here. And diffuse kind of works like multiply layer in Photoshop. And this doesn't have to be black and white. You can tint this with a color, but know that it's not going to be the exact color that you tint because it's going to kind of blend it with a kind of like a multiply mode. So in the luminance channel, he's building a layer shader here. So let's look in here. It's a Loomis with a Fresnel. So basically using Loomis for a specular hit, which is what you want to do, but he's using Fresnel to make sure that it falls off, so it's only being affected apparently toward the edges, I'm assuming here. Let me see. Turn that Fresnel off. I can't quite tell what's happening there. See, I'm digging through someone else's file, so just trying to show you how amazing this is without really understanding exactly how they built it. Another Fresnel on the reflection. So the Fresnel, the reflection only falls off in the outer part and doesn't affect the inner. So that's, okay, let's go back to that luminance. So that's what's happening in this Fresnel. It's reversed. So the Fresnel is only happening in the middle and not happening on the outside. Okay, so now your professor knows what he's talking about. No environment, fog, but we do have bump. And bump, again, is another layer mask in here. And let's turn these off one by one. The bottom is just the noise. The second one is another noise, but it's set to screen. So he's got two noises on here. And you'll see if I turn that off, you get one noise. This one kind of disrupts the other noise underneath it. Then he has a fusion set to burn mode and add a transparency of 71. But let's go in this here and see what's going on. He's got two noise channels, one with some dark settings and some flecks in here. The second one has some bigger, chunkier flecks. And then those two are fused together using exclusion to create this mask. And then that is blended with burn mode on top. And you can see when I turn this off, all these pits go away. And you turn it on and those pits come back. So this is a pretty clever way of getting some organic scratches and pits and dings in that metal. And then to top it off, even though he's using a Loomis channel, he's throwing in a really hard specular. Look at the height on this. He's got 1,000, a height of 1,000 on here. If we bring this down to 100, that's still pretty strong. And he's pushed it all the way up to 1,000. But you know what? I'm not going to argue, because if you look at that render in the picture viewer, those highlights look very photorealistic in here. And look at all the scratches and everything in here. Let's zoom in on this just to give it some more credit here. This is just a great, great little fantastic demo render. And again, I encourage you, get in that content browser, kind of look at the projects that are in there, open them up, do a little test render and see for yourself. And if anything catches your eye, start investigating and see how it's built, because that's basically the best way to learn. And that's how I learned how to do a lot of these textures, is just getting in there and poking around. So next up is that mountain. So here's the render from the example scene in your content browser. Now at first you say, wow, this looks really complex. And again, let's go back to Google real quick and let's look at these mountains in here. And the idea is you've got some geometry, the snow falls, gravity lets it settle on the flat parts and it falls away from the vertical parts. And that's what the fall off shader is going to do. So if we go into Cinema 4D, that's kind of what's happening here. It looks like all the horizontal surfaces are catching the snow and all the vertical surfaces are letting it drop off. And you think, wow, that's a really complex model. Somebody must have taken a long time to do this. And that's what I thought too. But look at this. This is really great. And again, this is in your content browser in most versions of Cinema 4D. Let's look at this file. Where's the mountain? All I see is a flat plane with some texture on it with kind of looks like stone, kind of looks like snow. But look what happens the second I hit the render key. And look how fast that renders. This is pretty remarkable. So what's going on exactly? Let's take a look here. Open up our material editor. And we've got a displacement layer. What is displacement? Now displacement, if you don't know already, lets you use a grayscale value map, much like a bump map, but it actually physically displaces the geometry in the scene. So for example, if I turn this camera off, we can see this scene from a different angle. The displacement is actually allowing this plane to take on the topology of a mountain. So let's turn off some of our layers here and start examining what's going on. For starters, the displacement is a stacked layer shader. So what it's doing, if you look at our lines in here, there aren't a lot of polygons on this surface here, but what's happening at the time of render, this displacement shader is saying, now take each one of those polygons and subdivide it 5 more times, which is important when you're trying to get resolution out of a grayscale map to displace something. So what's happening here is this person's used a layer shader with a bunch of these fractal noises again. So again, we're not using any textures to get that mountain. It's all being made up of these black and white images. Now what's really cool, if I turn on interactive render, let's open this up. If I look at this gradient, again, this is just a black to white gradient with a little bit of turbulence to get that organic edge. This is being used as a multiply mask around the outside edge. So that means anything that's white, allow everything below it to show through, but anything that's black, mask it out. And that's why the edges of this displacement map are flat. So if we turn off that gradient map, watch what happens. We get an entire mountain up here. And let me zoom out a little bit so we can see this more. So when we turn that gradient back on, it's just masking the outside edges and allowing the mountain to grow up from the middle. Otherwise, without it, the whole thing's shooting up everywhere. Now, also worth noting, let me put up the quality here on the render slider. As I change the topology of this mountain, look at how much more snow is on the flat surfaces here. This is that fall-off shader I was talking about. And as I turn that gradient off, we get more vertical surfaces and less snow. That's how mathematically genius this shader is, and this is why it's really exciting. So quickly, we'll just go through. We've got one of the noise shaders with some extreme scaling on it, blended in add mode with another noise shader, which is this wavy turbulence, which is giving these snowdrift feels to them, or rocky shale edges. And then a multiply with some dents in here, and all of these combined with each other in this layer shader. They're all stacked with blending modes of apply and multiply, and you see one by one, these each take on their own attribute of that displacement when they're all stacked together. And when they're all combined, we get this mountain shape. So let's go back to the camera mode, as the author intended us to see this scene here. And now let's take a look at this layer shader, this color layer shader. In here, we're stacking some shapes, so let's turn them all off. Let's go down one by one. And we're down to the base layer of this mountain, which is just made up of 2 shades of gray blended together with a Luca noise. That makes up the base of that mountain. Set to burn, there's another Luca with its own parameters with high and low clips that are kind of masking those out like we were talking about earlier. Those are then blended together in burn mode. Now again, this is just a color map, so it's not going to change the geometry like that displacement was doing. This is just adding these visual textures that are going on top of this to make it look like stone and rock and dirt and snow. We have another noise, more Luca, different scales. And then this is set to overlay mode on top of that. And you can see it's just adding some subtle variances, a little bit of tinier detail in there. And then we have this noise, which is 2 very bright white colors. And that noise set to normal at 100 on top of this thing. It's going to cover the whole mountain, and that's going to look like our snow. So the key is that fall-off shader, and that fall-off shader is not just being used direct onto the object, it's being used as a layer mask. So that means any material we create in this stack, in this layer shader, and we set it to a layer mask, it's going to, in essence, kind of like a track matte in After Effects or a layer mask in Photoshop, it's going to mask out the layer that's above it. So unlike After Effects, is kind of reversed. The track matte lives above the object. This one, it lives below it and it kind of clips it to it. So what is he doing in here? He's got a fall off shader and a noise shader. So the noise shader is basically set to overlay to roughen up that edge of this gradient. So it's just not this straight line across there. So the noise is just being used again as an organic fractal texture to kind of break up an edge. But the fall off, this is what's important here, is the direction. You've got X, Y, and Z. So you just put a number value of 1 in here just to say 1 is X, 1 is Y, 1 is Z. It doesn't have to, the higher number doesn't matter in this stack here. But this gradient is the key. So let's come back out here. Let's back up to and turn on our snow mask. And now you can see that snow layer is being affected by that fall off that's in this mask. So let's dig deep into that mask. And for fun, let's just change the gradient ramp. And you can see as I change the slider, that snow is going to fall less off of those vertical surfaces. It's going to stick more to those vertical surfaces. And again, you've got control over that mid-range where that knot's going to fall. And we can add even more snow or even less snow onto there by just moving this knot around. Okay, gives you a little bit more subtle fall off. I'm going to undo that because I don't want to mess up this guy's texture while we're still talking about it. That's basically how the fall off shader works. So what we want to do now from this point is let's look at the other layers. Again, he's got a diffusion layer in here. Remember, diffusion kind of acts like a multiply layer in Photoshop. And again, he's just using a noise shader to mask this snow mask. So essentially what he's saying is diffuse this mountain everywhere except for where the fall off is. So don't put any diffuse where the snow is going to fall. Then in the luminance channel, let's see what he's got going on. It looks like the snow gets some luminance using a Fresnel. And again, we've got our same fall off shader. We've got the noise shader, which is going to break up that edge of that fall off, and then all of that's being multiplied with a Fresnel. So that's saying just basically affect the outer edges of this snow in the luminance channel. So as the camera moves around, that's going to catch the light at different edges of here, as you can see if I turn that on and off. Right in through here, it's catching as the light wraps around away from the camera. It's getting kind of a light bounce off of it. It's pretty great. Onto the bump channel, turn this on. It's adding detail, more detail into that area. Again, it's using fall off shader in the snow mask. Same one that he's been using throughout. And different scales of noise. And this is just adding bump to the entire model on top of the default shading. The displacement is giving us the main topology of this mountain, but the bump is giving us the finer details in there. And again, we've got a specular layer in here, and it's really subtle. He's using a fall off shader and some noise on here on the snow. So again, this is a brief introduction. And again, I hate using somebody else's files to explain things, but I figured no better way to give you something to do, then go through your own content browser, find these files if you have them in the version of Cinema 4D that you have downloaded. And if not, just start poking around in there and start figuring out all these textures on your own, because they're such a handy resource to have right at your fingertips. And they came with Cinema 4D. But now, most importantly, what I want to talk about is this grape file here. This guy from Belgium, I can't pronounce his name, Marine Ravine. This is probably one of the most impressive files that comes in the content browser. And let's take a look in the picture viewer. This is the final render. And again, let's compare that to what we saw in Google for this image of these grapes. This is pretty darn impressive, considering there isn't a single pixel or Photoshop scan or digital image used in this. This is 100% computer generated image right here. I'm a huge fan of this guy. And the quick breakdown of this, He's got a sky object here. Let me, I have to close these up so I can see what's happening here. Here's the credit for this guy. He deserves it. Here's his website. Go check him out. Control tab gets that back. So you can see on the sky dome, we've got kind of an HDR image, but it's not a texture mapped image. If you look at the material editor in our luminance channel, it's a fusion, and what he's using is a gradient. He set some kind of sky, horizon, earth values in here, just using these knots and these blend modes. And then he's set one of those colors as this dark solid color, and he's just using a gradient to mask those two together. So basically using fusion, blend these two using this mask, right? So this becomes the HDR map on the sky dome that is used to light this scene, and he's using global illumination to do that. And he also has a couple settings in here, but he's got depth of field, physical render, global illumination, and that kind of plays key into the look of this thing. So global illumination, in my opinion, is kind of essential for this render. The other cool thing worth pointing out is he modeled all the grapes in a cloner and ran some dynamics, so when they fall into this bowl. So they all kind of land, so they're not intersecting each other. The real trick of this is, and again, this is a MoGraph thing, so if you don't have MoGraph, this isn't achievable, but in his cloner with the grapes, he's added a MoGraph effector called the shader. And if you look here under the shading, he's using a layer shader of two noises, black and purple blended with a black and kind of a maroon color. And what this is doing is telling the MoGraph cloner for every single one of these grapes that you clone in here, apply this layer shader so each one takes on whatever random value is. So it's basically going to take our grape material that we're going to create is going to create a consistent texture for every single one of these grapes, but this shader is going to affect each one randomly and make it a different value, so it looks like we've got far many more textures than we've built with just this one texture. For starters, what he's done, actually he probably did this last, but we're going to look at this first. In the color channel, he's just got some white color. But in the alpha, with a fusion, he's using two noises blended together, and this is creating an alpha channel for that white. And I don't know how well you can see this in here, but if I open this window, this is what's creating that kind of that waxy surface that's on the top of those grapes. Then if we open up the grape itself, let's turn off the displacement, the specular, the bump, the reflection, and the luminance. Let's just look at the color. Now I'm fascinated that he looked at a green grape and he decided, oh, let's make it pink. That to me is impressive thinking, just to be able to analyze something and know that the subsurface scattering is going to be what gives this thing the color, but the color itself is actually going to be this pink color. And he does this with a gradient, and again, this turbulence is taking all of these knots of these straight lines, and then when he adds the turbulence to them, they become wavy. Those get passed through a colorizer with a gradient, so they become these brown and green colors in here. Those get blended with the filtered, so basically he's just using a color shader of white and filtering it pink. I'm not quite sure why. But then the color gets set to screen over the top of those. So I don't know how well you can see. It's pretty subtle on my screen even, so I don't know. Oops, wrong one. Open window. There is a real subtle wavy line in here. And at this stage, it's probably not showing up very well, but I think once the subsurface scattering and everything starts to interact with that, that's where that's going to pay off. The luminance channel. This is the important channel here. He's creating some fusions between a gradient, and that the gradient is making up, this I believe is the top of the grape where it gets pulled off the stem, and this is the bottom point of the grape, and I could have those reversed, I'm not quite sure, but he's blending those two with a fusion shader, and then in his luminance, so again, we're in the luminance channel stacked we're a layer shader within a fusion shader, so it gets really complex. But he's using ambient occlusion as a fall off, as a layer mask. So let's try and understand what's happening there. Ambient occlusion basically looks at the objects around itself, and it has a kind of a fake shadow that it creates in between here. But instead of us using it to project the shadow, this guy's using it as a layer mask. So he's basically saying, if this area has any ambient occlusion in here, don't show this color set to multiply. I know that's a lot to get your head wrapped around, but basically it's saying, take our subsurface scattering, take this pink color, set it to multiply over the subsurface scattering, but don't include it wherever there's ambient occlusion in here. Very, very confusing, I know, but it's pretty genius. We've got another fusion shader in here, gradient mask that's always matching that stem top and bottom, and a noise shader. This is being passed through the layer of the subsurface scattering, and then the subsurface scattering itself has a color. So what's happening here is, we'll talk more about subsurface scattering later, but the light hits the object surface, and we're setting the path length that it's allowed to travel through and disperse that light. And then you have control over how far those specific red, green, and blue colors travel through that object as well. So with this carefully formulated, I'm sure he spent hours figuring this out, he's decided on the color when that light hits this pink thing, how much it's going to light up with the green. But then as it falls through, how much of the red is going to fall off further than the green and the blue, all the while using this fusion shader as a mask to obscure somewhat of that subsurface scattering. So there's so much going on right here on this one level alone. He's got some reflection, which is another fusion, again using that gradation, and another fusion of a Fresnel and some noise shaders. This just goes deeper and deeper and deeper. This is just fascinating. I could do a whole class just on this one guy's layer texture. We'll get into the bump here. It's looking like he's using the same gradation fused with a noise. Turn that on. And then his specular. Did he have specular on? I can't remember now. I think he did. And the displacement. And again, displacement, he's using a fusion between a noise and the gradient. And this is what's interesting here, is now the gradient is actually being used to tweak the shape of this grape. So as it gets dark at the top, it's going to curl in on those stems, and then it gets white down here at the bottom, and it's going to kind of push them out, and it's going to make them pointy at the end here. And you can kind of see here, let's open this up. Open this window. Look closely as this renders. Give it a second. So you can see this point here at the bottom. Now if I hold control and spin this window, there we go. I can spin this around in the window. Give it a second to render. Now you can see this black point here at the top of this gradient map is taking this displacement and pushing it in where the white was doing the point at the bottom. Pretty genius. All of that in combination. Let me revert this because I may have been messing around with the shader. So let's bring this back to where we had it. So now let's look at, let's turn off depth of field, and let's turn off global illumination for a second while we look at an interactive render region of this scene here. And it's going to take a second because it needs to calculate the subsurface scattering in here. But you can see the displacement is poking those little points out and dipping those little corners in. Opening up our material editor. Turn off our displacement, our specular, our bump, our reflection, and our luminance. And you'll see it's kind of boring, right? Let's turn off that Let's open up our grapes. Let's turn off that yeast for a second. Let's just put that up on another object temporarily. And let's turn off that shader I was talking about earlier. And you can see that shader, and again, remember, it's a fusion between two shades of purple. That shader is telling the MoGraph object to take every one of those clones and apply a different value off of this together. So you get this pile of random colors, even though without that shader, they're all just one solid color in here. So that's a pretty genius move as well. Back to the material editor. So we've got our color. We've got our luminance. Now this is where the subsurface scattering is going to come into play. The light's going to hit this object. It's going to penetrate through the surface, and it's going to light these up in between using a combination between this multiplied red on the surface, occluded from the corners, and the subsurface that's this bright green that's masked by this complex fusion layer in here as well. So this just goes on and on. Like I say, I could spend an entire class on here. The reflection has some Fresnel, and it's using layer mask, so it doesn't reflect in the stem hole in here. The bump uses that gradient mask, so it's going to start creating these grooves along the surface of these grapes. And then the displacement, of course, is going to give us the overall wobbly shape because he's got this large noise shader in here. So it's basically looking at the surface and it's displacing that perfectly round sphere. It's just creating some movement in there. So looking back at the final render, this guy deserves so much credit. Very impressive render. So I don't want to spend the entire class showcasing other people's projects, but we'll be building our own throughout the rest of this course. This was the introductory class. So what I wanted to do was show you these are objects and materials that ship with Cinema 4D. They're in the content browser. So I encourage you, get in there, open these projects, open the materials, start turning all of the buttons on and off and see what they do, and look how everything blends together to create these things. And hopefully it's going to inspire you like it did for me. And these specific examples that I'm showing here, these are the ones that really blew my mind and said, wow, look at all of the things that you can do in here. And that's what got me really excited about doing this, and hopefully it will for you too. So let me show you just quickly a couple of projects that I worked on as well. I needed to create a pickle for something, and there were no resources online for just a quick download of a pickle. So I said, let's just create one as fast as we can. So I did this all procedurally with shaders, but I also did parametric objects in here. Again, this tutorial is online elsewhere, so I don't want to bore you with the details of how I built all this, but I just have deformers in here. This is all modifiable, so at any time I could change the size, shape, and angle of the pickle. So it was a fun project to work on. But specifically, we're talking about the texture here. And let's look at the Google reference again. Some pickles here. You've got the rough skin. It's got some speckles on it. You've got some reflection because it's kind of shiny, a dull shiny finish to it. The bumps, the skin over the bumps get a little bit darker. You've got some speckles on here. You've got some rim light, like kind of a Fresnel fall off on here as well, and kind of a pattern on the surface. So the task here was, how could we create this all with procedural textures? So I'm using a layer stack in the color channel. The base is just a gradation set in UV, so that means on one end it's dark, and as it goes through the object to the other, it'll get light. Then that's stacked with a Fresnel, and this is what I was showing you earlier, where you can color tint a Fresnel, set it to screen mode, and if you turn this eyeball off the edge here, you can see that rim light is disappearing. So I'm basically faking a rim light with Fresnel around here, and it's catching all the displacement and the bump in here as well. And then I used the Varnois, again, that speckled noise. I scaled it way down and I pinched it using the high clip. And I'm using this as kind of a speckle map in here. I don't know how well you can see this, but there's these little white dots that are showing up. Again, I used the Varnois in the noise shader for the diffusion channel. And again, I'm using a bright green here because, remember, diffusion kind of applies itself as a multiply layer. So that green actually is going to be dark and the white's going to cancel itself out. In the luminance channel, I'm using a subsurface scattering. So when the light hits the surface of our green pickle, it's going to kind of scatter some brighter lime-colored light from within. And again, that's just looking at real-world reference of what a pickle, when you slice a pickle open, what's the color of the meat inside that pickle. And I set some custom color lengths for when the light hits that surface. And again, mess around with these numbers. I think I was just kind of still learning when I did these here. We'll play with subsurface scattering on a future project in our class here. Reflection, I just have a Fresnel, so the reflection is stronger on the edges than it is in the center. Kind of a dull specular on here to kind of give it that rubbery look so it doesn't look too shiny like glass. And then finally in the displacement, I've used the layer shader. I've got a base color just set to gray, because think of it like an overlay layer in Photoshop or a bump map. 50% is going to run you down the middle. Anything dark is going to sink in, and anything white is going to push out. So we start with 50%, and then I'm using this tile shader. And tile shaders are great because you have options like brick patterns, parquet floors, and by default these have colors in them, but what I did was I just stuck with lines, and they're alternating lines, and I guess I could have done that gradient when I just manually set up a bunch of knots across there, but that would have taken a long time. So just in one quick step, I was able to just drop a tile in here and change out the colors. Then I throw a noise on top of this. I'm using the cranial noise in the global scale set really low, but let me push this up high so we can see what's happening. This is the key to this texture. It has this kind of a quilty, ropey, twisty pattern happening in here with a pinch in the middle. So when this is set to black, it's kind of going to quilt the surface of this thing. So it's going to be puffy with almost a stitch in there. And then I set the scale down pretty low for this specific model. So it looks just like a bunch of noise in here right now, but at the scale that I built this pickle to, which is a real world scale, you'll see it in a second. Again, I'm using the Voronoi speckles, and that's all of these are combined together to create a gray scale map, and then that's being used as that displacement, and we're doing a sub-poly displacement at the time of rendering. So again, if I turn on the lines for this pickle, you'll see I've already subdivided this with a subdivision surface, or like a hypernerb. And now what I'm telling the shader to do is at the time of render, subdivide each one of these polygons 4 more times, and then apply that grayscale texture to it as a displacement map. And if we hit render here, you'll see quickly that Voronoi, those are those little bumps, and it's displacing there. And again, I use that Voronoi in the diffusion channel. And what I'm doing is I'm taking that same displacement Voronoi from here that is creating the bumps on the surface. I'm copying this channel, pasting it into the diffusion so all the parameters line up at the same coordinates. And that way I'm using the same pattern that's raising the bumps in the displacement, and I'm using the diffusion to darken those bumps, and that's how the skin on the surface of this pickle is getting darker. So for example, if I push this way down and render again, you'll see those dots get really dark on the surface here, or they should at least. They're starting to get a little bit darker. My subsurface is kind of counteracting that. Subsurface scattering is lighting that up. But you can see the darker I go with this dot, it's lining up because I'm copying the same parameters in here into the displacement channel. So my color texture lines up with my displacement texture. So that's quickly how I built the shader for the pickle. Now let's go into, finally, let's check out the eyeball. And this was one of my favorite ones to do because it's really simple geometry. It looks complex, but I have a hypernerb on here, or subdivision surface. So you can see it's relatively low poly geometry in here. And it's one shape that kind of has the scoop out for the iris area on here. And let me turn off the lines here. So if you look at the shader, oh, and one fun thing I want to point out in Google here, when we were looking at the reference of the eyeball, I saw the thumbnail for my eyeball in the Google search. I thought that was kind of funny. Okay, so back to the actual file here. If we take a look at what's happening, again, let's slide material editor off to the side. Let's open the color channel, because this is where most of the magic's happening, and I'll open this window up. And again, we'll keep the model over here in the background as well as here. I'm going to just turn off these layers one by one. And again, I'm just talking the theory of it more than the actual process. When we build our own textures later, I'll talk more about the specifics of how to build these. Right now, I just want to show you how these tools were used quickly to build it. Our base layer is a gradient. And again, it's just in the V mode. So it goes from the bottom of the object to the top. And I just carefully placed these knots and pinched them together, because you can see here on our model, this feathers out. And if I bring these knots closer together, they pinch. So it was just a matter of lining those up tight together, and they create a fine line right on the edge of the model where it goes. And we're doing a pink to white on the sclera as it approaches the edge of the iris here. That's the base layer. We're using a gradient mask with a turbulence that we were talking about. So that edge by default is this nice clean edge. I'm using turbulence in here set to 8. To kind of break that edge up, and that's being used as a layer mask. So let's not turn that on first. Let's see, what are we masking? I have a gradation, which is just black to brown in the V, so it goes from the bottom to the top, black to brown. And then we're using that gradient with the turbulence as a mask, and what that's doing, if you look right here, I'll turn the gradient off. So we've just got our blue here, turn the gradient on, that's using the mask. So the mask is limiting where that black to brown texture overlays there, and that's to give us sort of this organic speckles. And again, if you look at an eyeball, was the one we were looking at before, it's not all blue, there's some speckly light in here. So that's what we're achieving by just throwing this color at the edge of the iris. Then there's some great shaders in here, these water shaders, and again, these are really small. I'd be better off showing you the water shader on a new. Let's just come to the top. Let's do a water shader. And you can see this is by default, this texture is animated. So for what I wanted to do, I needed to turn the frequency and the wind off so it didn't animate. And the reason I used this is it had this really cool pattern. And again, this is used as a normal or a bump map to create waves on water. But when I looked at this, I thought, hey, I can take those knots of that gradient, pinch them together, and by doing so, I can create kind of a forced traced line. So that's what I ended up doing with this. Let me delete the one we just created. And again, the scale's kind of tiny in here. But by doing that and stretching it, I created this pattern that gets applied to the whole model. So what I did is using, again, a gradient, I set those knots to that same value. And again, you can get exact values. If you turn this gradient down and grab a specific knot, you can see the exact position of those knots. And if you grab the handles, you can see smooth knot in the 50% in between these two, and you can precisely set these knots up. So I was able to replicate that gradient every time I needed to use it as a mask. So again, I use that as a layer mask of that water shader, and then the water shader is only applied to the iris at the top here. You can see it disappears, and that's because this gradient mask is limiting where it goes. Again, we throw a Fresnel on here, so it kind of goes around the edge. And again, we do a gradient. We're going in the bottom to top, and this is going to be the color of the blood vessels that go throughout the sclera of the eye. So again, I used the water shader and I really pinched those knots together, and that's being used as a gradient mask, and that's masking. So this water shader here is being used as the mask of this gradient here, and that's what's creating the blood vessels on the surface. And we duplicate the gradient and throw a little turbulence at the end of it and duplicate the water shader and make the scale even smaller, and that gives us even tinier blood vessels in there. So that's it in a nutshell. I don't want to spend time going over old tutorials, and I don't want to spend the rest of the course talking about other people's projects. From here on out, we're going to do our own projects. This was an introductory class. This was showing you existing examples, both ones that I've created and things that ship with Cinema 4D in the content browser for you to dig around and get in, take these apart, look at them, see how they go, get your head wrapped around these things, start thinking about ideas of what you can do. And along the way, I'll throw some challenges at you and ask you to post some textures that you've created. So for now, let's wrap it up here. In the next class, we're going to talk about the material editor, how it looks in R15 and earlier versions compared to the new changes that we're going to see in R16 and future, which includes the absence of the specular channel that's been merged in with reflection. It's now called a reflectance channel. We'll talk about how we can still open legacy shaders in the new version R16. None of our old textures that we create will be lost, and it only gives us more functionality from the future here on out moving forward. And again, I understand not everybody's going to have R16 at the time of this initial release of this class, so we'll try to focus on building things with the legacy shaders, and every once in a while maybe we'll jump into the new reflectance. So I'll bounce around between R16 and R15 in the future. Thank you for sticking with us. I know this was a long class, but I just wanted to get all the fundamentals in the explanations of how this procedural shader works, so now we can hit the ground running. And post any questions you may have to the C4D 218 class on the FX PhD forum, and I'll do my best to answer them as quickly as I can to the best of my knowledge. I hope you have a great week, and I'll see you next time in class 2.